image classification using the keras CNN network. So this is the part of ICP 11. So here we are importing all the libraries, and this is the format of the data. So we have a channel name at the last, and this is the seeding. We are giving the 7 number for so that we can reproduce the same result. And here we are loading the data from the CIFR10. We are putting the data into the train and test, and then we are scaling the data by dividing by 255, which is the maximum pixel size of the image. And then for the output we are doing the hot encoding so that we'll get the result into the hot encoded format for the output. The data has been downloaded here, and if we are look for the shape of the input data, we have a 32 into 3. So 3 is the number of channels, and we have a size of the image by 32 by 32. So this is the model which has been given into the ICP. So we have implemented the same model, and later on we'll implement the model which has been instructed into the ICP so that we'll get the good performance on the model. So this is the we compiled the model here, and this is nothing but the summary of the same model, and we fit the data with epoch of 25. So total 25 epochs were run, and it was fitted over the train data, and for the validation data we have taken the test data here. So it ran for good amount of time. Then we evaluated the model over the test data. So we got the accuracy of 70.02%. For this model we got the accuracy of 70.02% on the test data. Then here with the name M1 we created the second model to see how the performance is changing over the same data. So we created the model as per given into the question. So this is the model which has been created, and then we compiled the model, and this is the summary of the model. So we have added so many convolution layer, dropout layer, and max pooling layer. We also use the flatten and dropouts, and at the end we created a dense layer with the 10 output because number of classes we have into the image is 10. Then here we fitted the model over the train data the same way we did for the previous model. So here the model name is M1, so we fitted the train data and the validation data. For the validation data we have taken as X test, and we ran for the same epoch like 25. So you can see like it has run for the 25 epochs, and then we evaluated the data over the test data. So here we get the accuracy of 80.23%. So it's far better than the previous model, because in the previous model we got around 70%. And then here we predicted the model for the test data. Like we did the evaluation, like we predicted the 4 image from the test data over the previous model. So previous model name is the model. So here we have predicted the image. So if you'll see here, the first one is 8, and also we have predicted value is 8, which is good. For the second also it's 8, 8. So this image is nothing but a ship. So this one is also good. The third one is not coming correctly. There is an error into it, and the fourth one is also correct. The same thing we did for the second model, that is nothing but M1. So according to this, the prediction is like we did for the first 4 image the same way. So in this model we are predicting correctly for the first three image, but the fourth one is coming incorrect. So it's again due to the accuracy, because the accuracy is only 88% in this case. And then we plotted the graph between graph on the accuracy and loss for both models. So this is the prediction. So this is our result, in which we have compared the accuracy for model 1 and model 2. So this is for accuracy and this one is for loss. So we have compared the model 1 and model 2. So the blue one and the orange one is for the training and validation data for model 1. So if you see, the blue line for the training is going high, but on the validation its performance is very low. So there is a huge gap. So it could be due to overfitting of the data. But the model 2 has a good performance. If you see, the green line is for the training and the For a red one is for validation, so there is a little bit gap. So this is good, and there is no as much overfitting which we have seen for the model 1. So the model 2 is better in the case of accuracy, and if you see on the validation data, so the red one is for the validation data accuracy is far better than the model 1. So model 2 is better, and if you see the lesser loss is good for a model. So if you see it here, the green one is for training loss and for the model 2, and the red one is for validation loss. So again, the loss is lesser in the case of model 2. If you compare the validation part, this one is for model 2 and the orange one is for model 1. So we got a lesser loss in the case of model 2. So overall, the model 2 has a better performance over the model 1. Then for the bonus question, we have saved the model into the H5 format here, and then I am loading the model, like we are reading the model, and we have given the model as a new model here, and we did the same thing, like I predict the first four image from as per the new model, and we predicted the image from the test data. So this is the result, which is nothing but the same as the our last prediction. In this case also the last image is not predicted correctly. So this is the part of ICP 11 for the Python class. Thank you.